Converting Moles to Grams, Part 2, by Mr. Thiel. Okay, here we have another problem where we are given a set number of moles for a particular element and we are asked to find the mass of that element in grams. So again, I have this diagram out of our textbook to help us to solve this problem. So first we write down what we are given. We are given 0.375 moles of potassium. So we are given the amount of the element in moles. And we are asked to find the mass of that number of moles of potassium. So we're asked to find the mass of the element in grams. Okay, so based on our diagram here, what we need to do is we need to use the molar mass of the element to find our answer. So first we'll write down what we are given. We are given 0.375 moles of potassium. So then once again what we will do is we will take this number of moles of our element and we multiply that times the molar mass of our element. Now to find the molar mass of our element we look to the periodic table. So when we look to the periodic table, we find potassium on the periodic table, and what we find for potassium on the periodic table is that it has an average atomic mass of 39.0983 AMUs. Now if we remember that the average atomic mass is numerically equivalent to the molar mass in grams, we simply take this number and plug it in to our equation to find grams from moles. So we're back at our problem now, and we write in our molar mass. That's 39.0983 grams of potassium for 1 mole of potassium. We got that from the average atomic mass of a potassium atom from the periodic table. And then if we run our equation through, we find that the moles of potassium will cancel out, and we end up with our mass of potassium in grams. So we get 14.661862.5. Obviously this number has too many significant figures. So if we go back and we look at the fact that we are given moles of potassium and we're given 3 significant figures there, and our average atomic mass has actually 6 significant figures, we are going to have to go with 3 in our final answer, so 3 sig figs. So we end up with a mass of potassium of 14.7 grams. So 0.375 moles of potassium is equal to 14.37 grams of potassium. And that makes sense if you want to sort of check our work. The molar mass, 1 mole of potassium is about 39 grams. If we have about 0.375 or 0.375 moles, we should have a little less than half of that. That's about 0.4. That's a little less than half of 1 mole. So our number of grams should be a little less than half of the number of grams in 1 mole. And 14.7 or about 15 is a little less than half of 39. So our answer checks out in that way. It's logical. It makes sense in that way as well. Okay, that's it for this problem.